Hello everyone, welcome to today's session. Today, after the completion of chapter 2, we are going to check out and solve top 10 expected board questions. So, let's go directly to the video. So the first question is, when does a force do work? As you know, force does some work when the displacement is in the direction of the force. When force and displacement are in the same direction. So I can write displacement is in the direction of force. The force is said to be doing some work. Okay, clear? Okay. The second part, what is the work done by the moon when it revolves round the earth? So moon is revolving round the earth in a circular path. So in circular motion, after one complete revolution, the displacement is always 0. The body comes back to its initial position. So I can write the work done by the moon is 0 since the displacement during the complete revolution is 0. Since displacement is 0 during complete revolution. So the work done will be 0. Okay? Yep. Number 2. Which physical quantity does electron volt measure? Carries 1 mark. As you know, electron volt is the unit of energy or unit of energy possessed by a subatomic particle. So I can write unit of energy. We need only short and crisp answer up to the point. It's a unit of energy. Okay. And second part, how is it related to the SI unit of this quantity? What is the SI unit of joule? SI unit of energy, it is joule. So how can it be related? So we have discussed in the previous session, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. This is the relation between electron volt and SI unit of energy. Clear? So 1 mark plus 1 mark, 2 marks. Alright. Next question. What should be the angle between force and displacement to get the minimum work and maximum work? 1 plus 1, 2 marks. To get the minimum work, we know that the formula for work done is equal to force Fs cos theta. This is the formula. Okay, whenever you get such question, please write the formula and explain. So to get the minimum work, the theta should be, the angle between force and displacement should be 90 degree. Because cos 90 is, what is the value of cos 90? Cos 90 is 0. So I can write W is equal to Fs cos 90, that is equal to 0. Since cos 90 is 0. Alright? Okay. So the work done will be 0 when angle between force and displacement is 90 degree. That is the value of minimum work. Okay, remember it is 90 is equal, theta is equal to 90 degree. And second part, to get the maximum work, as you know, the force and the displacement, the direction of displacement, the angle between force and displacement should be 0. So we can get maximum work when theta is equal to 0, because cos 0 is 1. W is equal to Fs cos 0. Cos 0 is equal to 1. W is equal to force into displacement. This is the case of maximum work when the force and displacement are in the same direction. So 1 plus 1, 2 mark. Alright, you have to write the formula and explain. Alright. Question number 4. A light body and a heavy body have the same kinetic energy. Kinetic energy is same. Alright. Which one will have the greater momentum? So in this context, you have to remember and recall the connection between, the formula connecting between kinetic energy and momentum. All of you must practice the formula. Otherwise, you are nowhere in physics. Your immunity in physics is very weak. So what is the formula? So we know that P is equal to under root 2 mk. This is the relation between kinetic energy and momentum, where k is the kinetic energy. Alright. So k is same here. Okay. So I can write P directly proportional to 2 is a constant root of mass. That is, what is the meaning of this expression? more the mass, heavier the body, more will be the momentum. So I can write heavier the body, more will be the momentum. So heavier body will have more momentum. All right, more momentum than light body. Okay, you have to write the formula and you have to logically explain it. All right, then you will get the full mark. Full mark will be awarded. Moving to question number 5. Name the physical quantity that is measured in kilowatt and kilowatt hour. Remember that all these questions are conceptual questions. You must learn or practice this type of question. These are 100% assured questions in the board examination. So as you know, the first part, kilowatt. So name which physical quantity is measured in kilowatt or watt? Of course, it is power. So right, power is measured in kilowatt. Very simple. Second part, kilowatt hour. So which quantity is measured in kilowatt hour? Is it power? No, kilowatt hour. It is energy or electrical energy. Better you write energy. All right, because power is equal to energy upon time, right? Or energy is equal to power into time, or energy is equal to power is measured in kilowatt, time is measured in hour. In this way, it has come. All right. So kilowatt hour is measured, the energy, the commercial unit of energy is kilowatt hour, and the SI unit of power is kilowatt or watt. All right. Okay. Next, question number 6. Give the relationship between 1 kilowatt hour and joule. So we have already derived this relationship in the previous lectures. Please watch those videos. So 1 kilowatt hour I can write. It's a 1 mark question. 1 kilowatt hour is equal to 1 kilowatt means 1000 watt into 1 hour. All right. So 1000 watt means 1000 watt. What means joule per second? 1000 joule per second. 1 watt means 1 joule per second into 1 hour. How many second? 3600 second. Okay. So I can write 1 kilowatt hour is equal to 3.6 into 10 to the power 6. How many? 1, 2, 3, 4, 5, 6. 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 megajoule. I can write megajoule, or 3.6 into 10 to the power 6 joule. This is the relationship between kilowatt hour and SI unit of energy, that is joule. Please remember this relation. Very, very important. Question number 7. A body is acted upon by a force. State 2 conditions when the work done is 0. You have to write the 2 conditions. You should be able to remember 2 conditions. So as you know, work done can be 0 when displacement is 0, when there is no displacement. When there is no displacement. All right. When there is no displacement. When S is equal to 0, force into displacement, F into 0 is 0. So become as I can write work done is equal to force into displacement. Okay. So first, second condition. What is the second condition? When work done can be 0 when the displacement is 0, or the angle between force and displacement is 90 degree. When theta is equal to 90 degree, because as W is equal to Fs cos theta. W is equal to Fs cos 90. Cos 90, the value of cos 90 is 0, right? So I can write W is equal to 0. So the work done can be 0 when either the displacement is 0 or the angle between force and displacement is 90 degree. All right? Yes. Question number 8. It's a direct question. State the principle of conservation of energy. All of you know the principle of conservation of energy is the statement. You have to write the statement as it is given in the textbook. Energy can neither be created nor can it be destroyed. It only changes from one form to another form. All of you write the statement. Okay. So what is the statement of principle of conservation of energy? Energy can neither be created nor be destroyed. It can only be transformed from one form to another form. All of you write the complete statement. And moving on to the second part of the question. Name the form of energy which a body may possess even when it is not in motion. When the body is not in motion, of course it will be at rest. So at rest, when the body is in waiting, when the body is at rest, it possesses potential energy. So it possesses potential energy. Don't write P, you have to write in full. That is potential energy. So you got 2 marks. Alright? Yes. Next question. Question number 9. Which would have the greater effect on kinetic energy of an object on doubling the mass or doubling the velocity? So as you know, kinetic energy is equal to half mv squared. Alright? That is kinetic energy K directly proportional to mass. Kinetic energy is directly proportional to square of the velocity. Alright? Because 1/2 is a constant. Therefore, doubling the mass, when you double the mass, kinetic energy will be doubled. On doubling the mass, K will be doubled. K will be doubled, as it is obvious from the equation. What happens when the velocity is doubled? Since I can write K directly proportional to V square, when velocity is doubled, what happens? 2 the whole square, that is 4. So when kinetic velocity is doubled, kinetic energy becomes 4 times of the initial value. Okay, so which will have more effect? The kinetic energy increases 4 times when we double the velocity. Therefore, doubling the velocity will have greater effect. Therefore, I can write doubling the velocity will have greater effect. Because kinetic energy is directly proportional to square of the velocity. Alright? Okay. So the last question of this session, question number 10. The work done by a fielder when he takes a catch in a cricket match is negative. Explain. Just explain taking the formula. So you connect the case with your day-to-day life situation. A ball is coming, just I am explaining, okay. The ball is coming with a certain velocity and the displacement is in this direction, and you are applying the opposing force to stop the ball. So what is the angle between the force and displacement? They are in the opposite direction, that is theta is equal to 180 degree. Alright. So this is the angle between the force and the displacement. Both are in the opposite direction. So we can write as W is equal to, work done is equal to Fs cos theta, and theta is equal to 180 degree, whose value cos 180 is equal to minus 1. What is the value of cos 180? Minus 1. So I can write W is equal to Fs cos 180, or W is equal to Fs minus 1. So W is equal to minus F dot S. The work done is negative. Alright, because the angle between the component of force and the displacement is 180 degree. When cos theta is 180 degree, work done will be negative. Okay, alright. So I hope this session was very useful to you. Practice this type of questions, and please do comment in the comment box so that I can make necessary corrections as per your wishes. Thank you very much.